Hi everyone at home, Mrs. Beckman here. Welcome to our lesson on graphs of events. I'm going to apologize ahead of time. One, I don't usually use PowerPoint, and two, I forgot my stylus at home, so it might be a little sloppy, but hopefully you'll still understand the lesson. All right, we're going to focus on two things today with graphs of events. The first thing being that you can interpret a graph. In other words, if I give you a graph, can you figure out what's going on in real life based upon that graph? And the second thing that we are going to cover today is that if I give you a situation or give you some information in today's lesson, I'm actually going to give you a video. Can you create your own graph based upon that video? All right, so those are the two things that we're working on today. Let's start with the first one. So I'm going to give you a graph. This is a made-up story, but we're going to pretend that all of the math teachers got a box of cookies as a Christmas present on Wednesday before Thanksgiving. The graph below represents the cookies left in the box after Thanksgiving. All right, so this is my box of cookies here. The first thing I usually do is I try to identify how many times our graph has changed directions. Well, this one's an easy one. Our graph has only changed directions. Well, it doesn't change directions. There's just kind of one line here. So I would put a 1 here. And then I would describe what is happening in that one line. So if I had to describe this, I would say Mrs. Beckman ate all of the cookies, and I know that because in the end, the amount of cookies went all the way down to the bottom, so I ended up with no cookies. And then I would describe how I was eating them. Did I stop? Did I take a break? Or was I eating constantly? And since the line is going down at the same rate the entire time, that means I must have been eating them kind of at a constant rate, just shoving them in my mouth one after another one. So it says Mrs. Beckman ate all of the cookies at a constant rate would be a good way to describe this one graph. All right, let's go to another math teacher here. Here we've got Mrs. Ball, or Mr. Hahn if you prefer, since he is taking the place of Mrs. Ball this year. She has, her graph's a lot more complicated. So let's go ahead and I'm gonna label the different parts of the graph. So there was one part. Again, sorry about the writing without my stylus. There's the second part where it changed directions. Well, it changes directions yet again. So third part and one last time. So there's 4 different things I definitely need to describe about what is happening in this graph. All right, so let me get my keyboard up here. So the first thing I would do is I would label 1, 2, 3, 4. All right, so in the first part, Mrs. Ball got her box of cookies. What did she do in line 1? If you notice, the box stays the same in line 1. So she waited to eat the cookies. Right when she got them, she wasn't hungry. Unlike me, she waited a little bit. So I'd say Mrs. Ball didn't eat any cookies in the beginning. Okay, after that, you look at line 2, the box of cookies, the amount of cookies, the line went down, so she must have eaten some. So Mrs. Ball, now did she eat all of them? If she did, it would go down to 0, and it doesn't look like she ate all of them. If I had to take a guess about what amount of the box that she ate, some people might say a half. It looks like she might have eaten a third. So Mrs. Ball ate a third of the cookies in the box. That would be the second thing that happened. Third thing, looks like she must have gotten full and stopped for a while because the amount of cookies remained the same. So Mrs. Ball stopped eating the cookies for a while. And then number 4, Mrs. Ball ate the remainder of the cookies until they were all gone. And that would be a good way to describe it. I think it's easiest when you number it, like I said earlier. All right, let's head to the last math teacher here. Mrs. Skates. All right, her graph is a lot more complicated than my graph as well. Let's see how many times her graph changes direction. So there's one, there's two, a third time, and a fourth time. So again, like Mrs. Ball, her graph changed 4 different times. All right, so let's describe those 4 different parts of the graph. All right, first part looks like, oh, Mrs. Skates might have also eaten about a third or a half. So let's say Mrs. Skates ate a third of the box. And notice compared to Mrs. Ball, her line went down a lot quicker. So what does that say about how fast she ate the cookies? And since it's going down quicker, it means that she must have been eating a lot quickly, or a lot quicker, sorry. So I'm going to say that Mrs. Skates, ate a third of the box pretty quickly. All right, and then like Mrs. Ball, she stopped for a little bit because the amount of cookies remained the same. So she stopped eating for a bit. All right, number 3, looks like she ate some more cookies. How much? Maybe another third. Mrs. Skates then decided to eat another third of the box. And you can even describe the speed. Was it the same speed as before? And if you notice, it goes down, but it doesn't go down as fast as the last time. So you can say that Mrs. Skates then decided to eat a third of the box slower this time. And number 4, we can say that she stopped eating the cookies. Did she ever finish her box of cookies? Unlike the rest of us, she did not. She must have gotten full or gave them away. So she stopped eating the cookies without finishing the box. And those are 3 examples of how, if you were given a graph, how you could describe what is happening in real life. So it's kind of amazing that just with one picture, you can tell all of this information of what is actually happening. All right, so if you go back to our objectives, you guys just did objective 1. You can interpret a graph. We're going to start on the second one, which in my opinion is a little bit tougher. I'm going to give you a situation and you have to make the graph. And just to make this a little bit more fun, we are going to do some videos. Mrs. Skates was awesome and embedded the videos into the lesson already. So that's why I'm using PowerPoint today. All right, so I'm going to play this video, and then your goal is to pause the video at any point or even rewind it and try to make a graph of what is actually happening in this situation. All right, so if you notice at the bottom, we always have time, and this time we're talking about seconds. So each of these video clips is 15 seconds long. And we are going to, in this video, be measuring the air pressure. So if you want to put air pressure here on the left side, we're going to see how the air pressure in the football is changing. All right. And if you need to, it'll also tell you what the scale is going up by. So if you need to, again, pause, feel free to pause. So the air pressure is going up by 1s if you want to fill out the scale going up and down on the graph. All right, seems simple enough. The guy was pumping up the football, but the thing is, can you get as much detail in as they showed you? How many pumps did the person do with um, the the pump, and then how many did they take a break, or did they just go consistently? So try to really watch that. In this next, it's going to show it again. This time it's going to be half speed. So let's see what you got. All right, if you haven't already, try to take a guess of what this graph looks like, and then it's going to show you the answer here in just a second. All right, so I'm going to pause here and just talk about some things that I would be looking for in your graph. I would look for, did you start at 0, and did you not start for a little bit? Because he did not start to pump air into the football until about 2 seconds. Then if you notice, it went up 4 times, so I would look for those 4 times. Now, in between, he had to pull it back up, and so when he was doing that, the air pressure did not change. So notice it went up, stayed the same, up, stayed the same, up, stayed the same. And then right around 8 seconds, he felt the football to see if it was full of air, and then realized it wasn't, and he did 2 more pumps of air, and then he finally felt it this time, and it was good. Okay, now obviously you don't know exactly how much air pressure was in there, but I am looking for this shape of graph in the end. So hopefully you guys did okay on that one. Let's try another one. This one always makes me laugh. Okay, this time again, seconds at the bottom, and the title and what goes on the left side here is the distance that this bar is from the bench. That's what you are looking for. How far off the bench is the bar? All right, especially think about, where did the bar start, where did the bar end, and then try to fill in the details as much as possible. Again, watch it half speed. All right, you may need to pause now to sketch your graph. And then here is the answer. All right, so here are some of the things that I'm looking for. Now, you obviously don't know that it starts exactly at 3 feet off the ground, but you should know that it starts up in the air before going down. Another thing I'm looking for is that it does not go down to 0, else you just killed the guy. So make sure that the bar does not go through his body. It stayed, it looks like it was about 1.5 feet off the ground. Again, or off the bench, you wouldn't know that. But as long as it doesn't go all the way down to 0, I'd give you credit. Then did you go up 3 more times? Because he did 3 more deadlifts. And then did you show his struggle to try to push the bar back up and then finally in the end um, getting it back to the top? Okay, so those are some of the details I'm looking for. Let's try one more. We're going to do 2 left. Here's the next one. This one is going to be still 15-second clip in elevation. We are looking how far off the ground this person is. And I shouldn't say off the ground, I would say how far off the water. So imagine that this person is on a bridge and there's water below him. So imagine that the bridge goes over the water. And so the person is going to start kind of right here. And we are saying how far off the ground or off the water down below here is the person. So think about where he's starting in this picture. And if you want to, you can put that the feet off the ground are going up by 5s. All right, same video, half speed. All right, pause now if you needed time to sketch your graph, and then here is the answer. Okay, so things that we would be looking for. Did your person start off the ground? Again, you're not going to see that that person started 35 feet off the ground or off the water level, but it should be starting up in the air. Should have went up. It should have kind of stayed the same at one point and then went back down. Now notice it does not go back down to 0. He doesn't end up in the water. He ends up about the same height that he started. All right, one last video. This time a person is going to be driving and you are watching their speed. I believe the scale going up and down is by 5. So if you want to label the scale, go ahead. But you're watching this driver's speed. All right, half speed. Feel free to pause now if you need to have time to sketch your graph, and then here's the answer. All right, on this graph, you could give a little bit more detail because you could see the actual speed. So did your speed start at 50 miles per hour? And did it stay there for about 3 seconds? Because that's what happened on the video clip. And then they were getting ready to turn, so they kept decreasing in speed pretty consistently. And at the very end, the speed of the car finally got down to 0. So those are the parts that we would be looking for. All right, so that sums up the last of our lesson. We now have hit the 2 important parts. So given a graph, being able to interpret the situation, and given some information or a situation that you could create your own graph. Hopefully this video is helpful. There is a homework assignment, but I have also provided answer key if you need to check it. Please don't hesitate to reach out if you have any questions on it. All right, see you guys.